It begins with silence. Not the silence of a room after the last word has been spoken. Not even the silence between heartbeats. This silence was older, deeper, the kind that existed before there was time to measure it. And then a spark. Not a sound, not a flash, but an awakening. Everything that would ever be, every atom, every galaxy, every heartbeat, every question, compressed into something smaller than the smallest thing you can imagine, suddenly decided to expand. This was the universe's first breath. It wasn't an explosion, not really. Explosions happen in space. This was space itself expanding. Everywhere, all at once. Not outward into something, but making outward as it went. Imagine a balloon. Now imagine you're not watching it from the outside, but living inside it. And as the balloon stretches, the very air between your lungs expands with it. That's what the universe did. That's what it's still doing. In that first trillionth of a second, everything was pure energy. No stars, no matter, no light as we know it. Just a storm of potential, hotter than any furnace, denser than any thought. Then, slowly, the universe cooled, like a newborn taking its first deep breath. Energy condensed into particles, quarks and electrons, the seeds of atoms, and for the first time, the universe began to shine. Light itself was born. The ancient light is still traveling, even now, stretched and softened by billions of years of expansion. We call it the cosmic microwave background, the afterglow of creation. If you've ever seen the static of an old TV, a tiny fraction of that noise is the echo of the Big Bang itself, a whisper from the first dawn. In those early moments, the universe was smaller than an atom, and then, in less than a heartbeat, it was the size of a galaxy. Space didn't just grow, it inflated. An era we call cosmic inflation, when expansion outran even the speed of light. Not because light was too slow, but because the light's racetrack was stretching faster than it could run. That's the strange thing about expansion. It doesn't pull galaxies through space. It stretches the fabric of space itself. Every atom, every photon, every breath of existence, riding along the tide. We often imagine the Big Bang as something that happened somewhere, but it didn't happen at a point in space. It happened everywhere, even now, even here. the atoms in your body were once compressed into the same beginning. You're not made from the universe. You are made of it. You have been expanding since the very first breath. Billions of years later, we gaze up at the night sky, and what we see are fossils of light, ancient messengers traveling across the stretching fabric of time. Every star we see is a memory, every galaxy a snapshot of what once was. And yet, while we look backward, the universe keeps moving forward. It doesn't stop, it doesn't rest. The same expansion that began 13.8 billion years ago still hums beneath the surface of everything. Galaxies drift farther apart. Clusters loosen their cosmic grip, and the space between them, that invisible, ungraspable nothing, grows larger with every passing second. If you could stand outside it all, though you can't, you wouldn't see an explosion fading into the dark. You'd see the dark itself stretching, an endless unfolding, a breath that never quite exhales. Maybe the universe is still expanding because it has never stopped dreaming. Maybe it is still unfolding because there are still stories to tell, still stars to be born, still minds to wonder, still hearts to ask. Why? Because that's what we are, the universe, wondering about its own beginning. Chapter 2: The Silent Drift. If you look up at the night sky long enough, it feels still. The stars seem frozen, as if someone has pinned them carefully to a velvet dome. But that stillness is an illusion, because everything you see, every star, every cluster, every glowing thread of the cosmic web, is drifting. Slowly, silently, relentlessly. In the vastness of the cosmos, galaxies are like islands of light, adrift on an invisible ocean. But it isn't the galaxies that are moving through space. It's the space itself that is swelling, carrying them apart. The universe is not expanding into something. It's making more of itself. Imagine dots drawn on a balloon. As the balloon inflates, the dots move farther apart. Not because they are traveling, but because the space between them stretches. That's what's happening all around you, all the time. Right now, in the moment you are listening to this, every galaxy, farther than a few million light years away, is retreating from us. Its light stretched, its voice red-shifted, its story elongated across time. If you could ride a beam of light and chase one of those galaxies, you would never catch it. because the space between you and it would keep growing faster than you could ever move. And yet, from within our tiny corner, it doesn't feel that way. Earth spins, the moon circles, the sun burns, and the stars above us seem steady, eternal. But over billions of years, the silent drift reshapes everything. Galaxies that once huddled close will one day vanish beyond sight. The light stretched so thin it will never reach us again. The night sky itself is expanding, a painting being slowly pulled apart. It was in the early 20th century that humans first began to realize this. A man called Edwin Hubble, working late nights with the telescope at Mount Wilson Observatory, noticed something strange. He measured the light from distant galaxies and found that almost all of them were shifted toward red, as if they were moving away from us. The farther away the galaxy, the faster it seemed to recede. This was not chaos, it was pattern, a rhythm written into the structure of reality. The universe was not static, as even Einstein once believed. It was expanding. And Hubble's discovery changed everything. For the first time, we understood that the cosmos was not eternal and changing. It had a beginning, and it had motion. It's strange to think about it, that the light from those distant galaxies left billions of years ago, before even Earth existed, and only now, after traveling through the expanding fabric of space, has reached your eyes. Each photon that touches your retina tonight has stretched and softened through an ever growing universe, like the echo of a song traveling through fog. That's what astronomers call redshift. Not just a color, but a clue, a sign that space is stretching, that time is moving outward, that the universe is still breathing. And yet, here's the most haunting part: there is no center, no edge, no middle of the expansion. From every point, the universe appears to be moving away. From every galaxy, the same redshift hum can be measured. No matter where you stand, it feels like you are at the center of creation. That's because, in a sense, you are. Every point in space is expanding away from every other. Every observer sees the same cosmic truth. The universe has no single center because it is the center. That means this little blue planet, orbiting an average star at the edge of an average galaxy, is as central to the story of the cosmos as any other place. You are not at the edge of anything. You are inside it all. And maybe that's comforting, because if the universe expands everywhere at once, then even the smallest spaces, the pause between your breaths, the silence before you fall asleep, are part of the same unfolding. Every cell in your body is expanding, not enough to feel, but enough to belong. You are drifting with galaxies, riding the same invisible current that began 13.8 billion years ago. It's easy to think of cosmic expansion as something far away, something happening in the deep vacuum of intergalactic space. But it's not out there, it's here. You're floating in the same ocean of space-time. The same silent drift carries you. The same cosmic wind shapes you. The same breath of the universe moves through you. If you close your eyes, you might almost feel it. A faint hum beneath everything. The stretching of the invisible. The slow dance of the galaxies moving apart like fireflies that forgot where home was. But there's no tragedy in that drift, only wonder. Because even as the universe expands, it still holds us together in gravity, in memory, in light. Everything is moving away, and yet somehow everything remains connected. Chapter 3: The Measure of Nothing. What does it mean to measure something that cannot be seen? How would you take the size of nothing? To understand the expansion of the universe, we first had to understand emptiness. But emptiness, as it turns out, is not empty at all. Between every galaxy lies a vast ocean of nothing, or what we once thought was nothing. No stars, no dust, no sound, just the quiet hum of space stretching itself thinner. But even this silence carries a memory, a faint invisible glow that seeps through the cosmos like the echo of a dream. That glow is the cosmic microwave background, the oldest light in existence. If you could tune your radio between stations, you'd hear it. A soft hiss, a whisper from the universe's childhood, leftover radiation from when everything was hot, dense, and glowing. Roughly 380,000 years after the Big Bang, the universe finally cooled enough for atoms to form. For the first time, light could travel freely, no longer scattered by the chaos of charged particles. That light has been traveling ever since, crossing billions of years of expanding space, stretched and red-shifted into microwaves so faint that only the most sensitive instruments can detect them. And yet, it's everywhere. It passes through your body as you listen to this, through walls, oceans, and mountains, through the fabric of the earth itself. It's the soft afterglow of creation, a message written across the sky in wavelengths too ancient to fade. In the 1960s, two scientists, Arno Penzias and Robert Wilson, were working with a large antenna in New Jersey. They were trying to remove an annoying background noise that kept interfering with their instruments. They cleaned the dish. They chased away the pigeons nesting inside it. But the noise remained, a constant, gentle static. What they had stumbled upon was not interference. It was the voice of the cosmos. They had accidentally discovered the cosmic background radiation, the faint echo of the Big Bang itself. That moment confirmed what theorists had long suspected, that the universe had a beginning and it was still expanding. But that discovery raised an even stranger question. If the universe is expanding, what exactly is it expanding into? The human mind wants edges. We imagine boundaries, a bubble growing into a larger void. But space doesn't expand into nothing. It expands within itself. It's not like air filling a room. It's the room itself getting larger. The walls moving apart. The floor stretching. The ceiling rising. And what's beyond that room? Nothing. Because beyond doesn't exist. Not yet. The universe creates its own space as it grows, like a story writing its own pages as it's told. So, how do we measure something that has no edge, no boundary, no frame of reference? We measure light. When light leaves a distant galaxy, it travels through the stretching fabric of space. And as space expands, the light itself is stretched. Its wavelength grows longer. Its color shifts redder. That's why astronomers call it redshift. By studying that redshift, we can trace how fast galaxies are receding and how much the universe has stretched since the light first began its journey. Each photon that reaches us carries not just energy, but history. It tells us how the universe looked billions of years ago. It tells us how much space has expanded since then. And it whispers, with patient certainty, it's still growing. But there's a quiet strangeness hidden in all this. As we look farther out into space, we are also looking back in time. The galaxies we see 10 billion light years away are not as they are now, but as they were when the light began its journey, when the universe was young and wild. In that sense, telescopes are not just eyes, they are time machines. Every image of a distant galaxy is a fossilized moment of cosmic history, a glimpse into the universe's own diary. And yet, as the light continues to stretch, there will come a time when those galaxies slip beyond our view, their glow stretched so thin that no telescope will ever find them again. In the end, we are surrounded by ancient light and endless dark, by evidence of a beginning and the promise of continuation. Space, as it turns out, isn't empty. It's alive with possibility, with virtual particles flickering in and out of existence, with the hum of dark energy we cannot yet see, with echoes of stars that burned out long before Earth was born. Even the silence between atoms is full of invisible tension, a vibration, a quantum uncertainty, as if the universe can't help but hum quietly to itself. Nothingness, it seems, is just another kind of fullness, too subtle for the eye, too vast for the hand. And that fullness, that mysterious invisible energy woven into space, might be the very thing that keeps the universe expanding still. Maybe the secret of the cosmos is this, that even the emptiest part of existence are never truly empty. Maybe the reason the universe expands is because it was never meant to stop becoming. Chapter 4. The breath accelerates. For most of human history, we imagined the heavens as still and perfect, a grand clock, wound once and forever ticking in balance. Even after Hubble's discovery that galaxies are drifting apart, scientists assumed that this expansion must be slowing down. After all, gravity is patient. Given enough time, it pulls everything back together. The universe, they thought, would one day grow tired. The stars would fade, galaxies would collide and merge, and perhaps, after eons of expansion, everything would fall inward again. A cosmic inhale after an endless exhale. In the late 1990s, two teams of astronomers were studying supernovae, the brilliant deaths of massive stars. Supernovae are more than just cosmic fireworks. They are measuring sticks, because certain kinds, known as type Ia supernovae, always explode with the same intrinsic brightness. By comparing how bright they appear from Earth, scientists can tell how far they are. It's like seeing identical light bulbs scattered through space. Their dimness tells you their distance. So, by mapping these cosmic candles, the teams hoped to measure how fast the universe's expansion was slowing down. But what they found instead was something that shook the foundations of cosmology. The farthest supernovae looked dimmer than they should have been, much dimmer. That meant those galaxies were not just far away, they were farther than expected. as if the universe had been expanding faster in the recent past than it had before. The conclusion was staggering. The universe's expansion wasn't decelerating, it was accelerating. Something was pushing galaxies apart. Something invisible, something powerful enough to overcome gravity itself. They called it dark energy. Dark energy makes up nearly 70% of everything in existence. And yet, we don't know what it is. It doesn't shine. It doesn't clump like matter. It doesn't leave fingerprints we can easily see. It's not dark in color, it's dark in understanding. All we know is this: it behaves like a kind of negative presence, a force embedded in space itself that pushes instead of pulls. As the universe grows, so does dark energy, because the more space there is, the more room there is for it to exist. It's like the universe is feeding its own expansion, a self sustaining breath. Einstein, decades earlier, had almost predicted this. When he first developed his theory of general relativity, it suggested that the universe should be either expanding or contracting. But at that time, no one believed it. So he added a mathematical tweak called the cosmological constant, a term meant to balance gravity and keep the universe static. Later, when Hubble discovered expansion, Einstein called that adjustment the greatest blunder of his career. But now, a century later, that same idea, a mysterious energy filling empty space, had returned, and it fit the data almost perfectly. Einstein's blunder might have been the universe's greatest secret all along. So, what is this dark energy? Where does it come from? Why does it make the cosmos speed up instead of slow down? There are many ideas, but no final answer. Some believe it's a cosmological constant, a fixed energy that simply is, woven into space-time. Others think it might change over time, a dynamic, shifting quintessence, like an invisible tide moving beneath reality. Still, others suspect that dark energy isn't a thing at all, but a sign that our understanding of gravity itself is incomplete. Perhaps the equations that describe space and time are whispering to us in a language we haven't yet learned to hear. Whatever it is, its effects are undeniable. Every second that passes, the space between galaxies grows larger. Clusters drift farther apart. Light stretches thinner and thinner. And this expansion is not slowing down. It's racing ahead faster than ever before. In billions of years, distant galaxies will disappear from our view entirely. The light will fade into infrared whispers. and vanish beyond our cosmic horizon. One day, the Milky Way and its neighboring galaxies will be alone in an ever darkening sky. The stars we see tonight, the patterns we use to navigate, to tell stories, to dream, will one day vanish into silence. And maybe that silence isn't sad. Maybe it's simply the universe continuing to breathe, to create, to expand into more of itself. Dark energy might be the quiet will of existence, the part of the cosmos that refuses to stop unfolding. Perhaps, in some poetic sense, it is curiosity itself, the drive to keep going, to see what lies beyond. The universe has no destination, no finish line. It only has motion. And maybe that's enough. When you breathe in, your lungs expand, stretching the air that surrounds them. The space inside you grows, not because there's more air, but because you've made room for it. Maybe the universe is doing the same. A vast inhale, still happening after 13.8 billion years. And maybe dark energy is simply the universe's way of remembering how to keep breathing. Chapter 5, Edges of Forever. What does forever look like? It's a question that seems poetic, almost childlike. But in the language of the cosmos, it's also a scientific one. Because if the universe is expanding and accelerating, what happens next? Where does it all go? Does expansion go on forever? Does it slow down? Does it tear itself apart? No one knows for certain. But science, like imagination, has its way of peeking ahead. The first possibility is the quiet one, the big freeze. If dark energy keeps its steady pressure, galaxies will continue drifting farther and farther apart. Stars will burn their fuel, new stars will form more rarely, and one by one, the lights will go out. In trillions of years, even the last red dwarfs, those stubborn, slow burning embers of the cosmos, will fade into blackness. No new light will be born, no new warmth. The universe will keep expanding, colder, darker, emptier, until there's nothing left to see or feel. It's not an explosion, it's a fading, a soft eternal sigh. The second possibility is more dramatic, the big rip. If dark energy's strength grows with time, if its push becomes more powerful as space expands, then one day gravity will lose completely. Galaxies will first drift apart, then solar systems will unravel. Planets will slip from their orbits. Atoms will tear themselves apart. Even the very fabric of spacetime will shred. A universe unmade not by fire, but by separation. Everything pulled away from everything else, and then silence. A cosmic disassembly. No heat, no matter. Just the fragments of once connected things drifting into mathematical nothing. A forever without form. The third possibility is more mysterious. The big bounce. Perhaps expansion will one day slow. Perhaps dark energy will change its nature and gravity will regain the upper hand. The universe could stop expanding, then collapse inward, a mirror image of its beginning. Galaxies would fall toward each other, matter would crush and heat, and eventually everything might return to a single blazing point. And then maybe it all begins again. A new Big Bang, a new cycle of time, the universe reborn, forever breathing in and out, creation and collapse, a cosmic heartbeat without end. We don't know yet which story is true. Maybe none of them are. Maybe the universe holds an ending no mind has yet imagined. But whatever the outcome, it teaches us something profound. The universe is not infinite in time, but it may be infinite in becoming. It never stops changing, and change, even in the face of decay, is a kind of life. When we talk about forever, we often imagine stillness, a heaven that doesn't move, a peace that doesn't shift. But the universe teaches us the opposite. Forever isn't still. Forever is motion without destination. Even entropy, the slow slide toward disorder, isn't the end of everything. It's transformation, matter rearranging into new forms of quiet. The atoms that make you will someday drift into that cold, expanding dark. But they will still be there, spread thin, yes, but eternal. Your carbon, your oxygen, your light. You will not vanish, you will only become more spacious. There's a strange beauty in that, because when you realize that even galaxies die, even time stretches thin, you start to see how precious this moment is. This blink in cosmic time, the one where stars still shine, and warmth still flows, and minds still wonder, is a miracle of timing. We exist in a narrow window, a brief pause between darknesses. The stars have not yet faded, and the sky is still full of stories. We are living inside the light. And even if the universe cools, even if galaxies drift beyond sight, that expansion, that outward motion, is still a kind of love. Not the human kind, but the cosmic kind. The love of becoming. The drive to continue. The universe expands because it is compelled to unfold. And we Its sinking fragments carry the same impulse inside us. We build, we explore, we reach for more because somewhere deep in our atoms, the memory of the first expansion still lingers. It whispers, keep going. So maybe forever isn't about time at all. Maybe it's about motion, the endless blooming of space, the never ending reach toward possibility. Forever is in the end, it's the refusal to end. And if the universe has no edge, then perhaps neither do we. Chapter 6: The Fabric and the Fold. Time is a strange companion. It never walks backward, but it doesn't move the same for everyone. To some, a second is a heartbeat, to others, a century, and to the universe itself, time is elastic. It bends, it folds, it stretches with the fabric of space. Because in the cosmos, space and time are not separate threads. They are one cloth, woven tightly together. When space expands, time expands too. When gravity curves the fabric of reality, it slows the rhythm of clocks. Einstein taught us thus that time is not constant, but relative. It depends on where you stand and how fast you move through the cosmic tapestry. Imagine the universe as a great sheet, a woven field of space and time. When galaxies form, their gravity presses into it, creating depths like footprints in sand. When light passes near those depths, its path curves, and when the universe expands, the whole sheet stretches outward, the grains of sand spreading, the dimples flattening, the distance between footsteps growing. But the sand itself, the very texture of reality, becomes thinner. The rhythm of existence slows. If you could watch the universe's clock from the outside, you'd see that it ticks faster now than it did billions of years ago. In the early universe, everything was denser. Gravity was stronger. Time moved slower. Now, with space stretched and gravity diluted, time flows more freely, like water finding a wider river. This is not poetry, it's physics. As galaxies drift apart, as dark energy accelerates the expansion, the rate at which time unfolds is itself changing. Every heartbeat you feel, every second that passes, is carried on that same invisible current. This stretching of space has other, subtler effects too. It changes how light travels, how we see the cosmos. When a photon leaves a distant galaxy, its wavelength stretches with the universe. That means it not only travels through time, it becomes time. Every red-shifted photon is a memory of expansion. Every faint glow we observe is the record of time lengthened, like a song slowed down by distance. When we look through a telescope, we aren't just seeing far away, we are looking into slower moments. We are peering into a past where time ticked at a different pace. Each galaxy is a clock, each star a second, each photon a whisper of what universe once felt like. It's easy to think time as a line, a straight arrow from then to now. But the more we learn, the more it looks like a landscape, not a path you walk, but a terrain you exist within, where different paths unfold at different speeds. Some regions of the universe might be older or younger, not because they began later, but because their time flows differently. That's the strange, humbling truth. Even now is not the same everywhere. There is no single cosmic clock ticking in unison, only a vast symphony of rhythms, some slow, some fast, playing together in the great unfolding of space. And if that's true, if time stretches as space expands, then maybe our experience of the universe's age is only one perspective. From another vantage point, the cosmos could still be young or unimaginably old. Time doesn't just move through the universe, it belongs to it. It's born, shaped, and stretched by the same forces that move the stars. And here's something to wonder: if space can stretch, if time can bend, if everything we see and feel is made of this same pliable fabric, then maybe consciousness too rides its folds. Maybe every thought you ever had, every dream, every spark of curiosity exists somewhere on the same fabric, a pattern, a vibration woven into the tapestry of space-time. Chapter 7: The Vanishing Sky. Look up. The night sky you see tonight, scattered with stars, streaked by galaxies, veiled by dust and time, is a temporary masterpiece, a snapshot in cosmic adolescence. Billions of years from now, this familiar sky will fade. The constellations you know, the stories written in Orion's belt and Cassiopeia's crown, will drift apart, their stars carried away by the stretching fabric of space. The sky will empty, and the darkness will grow deeper than we can imagine. Right now, the Milky Way belongs to a large cluster, a web of galaxies bound together by gravity. We call it the local group. Our Milky Way galaxy, the great spiral of Andromeda, and dozens of smaller satellite galaxies, all gently orbiting one another. In a cosmic dance that has lasted for billions of years. In about 4 billion years, the Milky Way and Andromeda will meet, not in a violent crash, but a slow, graceful merging. Stars will weave past each other. Gravity will sculpt new patterns, And from their union, a single giant elliptical galaxy will form, its stars glowing faintly in the thinning dark. Astronomers already have a name for it: Milk Dromeda. But even that grand union will be only a brief moment in the vast future of the cosmos. Because beyond our local cluster, everything else is retreating. The galaxies of the Virgo cluster, the shimmering threads of the cosmic web, the deep field lights captured by the telescopes, they are all moving away, their light stretching redder and redder until it slips beyond visibility. One day, not so far in cosmic time, no telescope, no matter how powerful, will see beyond our local group. The rest of the universe will fade from view. Not because it's gone, but because the space in between has grown too wide for light to cross. Imagine the future astronomer, billions of years from now, standing on a world orbiting some quiet red star. They look up and only see their own galaxy. No cosmic web, no scattered galaxies in the distance. Only the faint halo of their local stars. They will measure the heavens, but see no evidence of expansion, no cosmic background radiation. Its ancient whisper, too faint to hear. To them, the universe will appear still, eternal, just as it once did to us before Hubble turned his telescope to the stars. The irony is almost poetic. The more the universe expands, the less of it will remain visible. The faster it grows, the more it hides itself. The cosmos, in its eagerness to become, slowly erases its own reflection. In that far future, the night will be darker, colder, emptier, but perhaps not lonelier, because by then, whatever consciousness exists will know what we now know, that even when the light fades, the connection remains. Listen closely. Can you hear it? That faint hum beneath everything. The sound of distance growing. The heartbeat of creation that never stopped. The universe is still expanding. Even now, as you sit here, as galaxies slip further into the dark, as time stretches gently between stars, space itself is unfolding. Each moment is a little larger than the one before it. And though we can't feel it, we'll live inside that motion. We are that motion. It's strange, isn't it, to think that all of existence is still becoming. That even after 13.8 billion years, the universe hasn't settled. It's still learning how to breathe, still reaching, still opening, still growing into whatever it was meant to be. And maybe so are we. There's something deeply human about this endless expansion, because you too are still unfolding, Every thought you have, every dream, every loss, every act of love, it expands you, not outward like galaxies, but inward, into the vastness of what it means to exist. Just like the cosmos, you began small, a point of infinite potential, and with each moment, you've been stretching, creating space for new experiences, new understanding, new light. The universe expands in space. You expand in soul. Both are acts of becoming. When we talk about expansion, it's easy to imagine distance, things drifting away, connections fading into cold. But expansion is also creation. When the universe stretches, it makes room for more stars, more stories, more possibility. Every new centimeter of space is a stage waiting for something to exist upon it. And maybe that's true for us too. Maybe growth always begins with the courage to make space for something new. Space to change, space to forgive, space to dream. It's humbling, isn't it? To realize that we live in a universe that never stops moving forward. That nothing, no matter how vast, is ever static. Galaxies evolve, stars die and are reborn. Even atoms shift between forms, never lost, only rearranged. And if that's the law of the cosmos, then maybe it's also the law of us, that no moment is ever final, that endings are simply transformations in disguise, that you, like the universe, are allowed to keep expanding, to keep becoming something you haven't yet imagined. There's comfort in that, I think, because so much of life feels like contraction, grief, fear, the closing of chapters. But even those moments are part of a larger rhythm. Every collapse, every heartbreak, every failure is a kind of gravity. And gravity doesn't destroy, it reshapes, it gives birth to stars. The same physics that pulls galaxies together turns gas into light. The same force that can crush can also create. And even when you feel small, when your world feels like it's shrinking, remember that's just one half of the universe's breath. The inhale always follows. One day, far into the future, the stars will fade. The cosmic background will fall silent, and time itself may slow until it feels like eternity. But even then, the universe will still be. Even in its quietest form, it will remain vast, mysterious, and full of potential. Because expansion isn't just about motion, it's about persistence. the refusal to stop unfolding. So, when you feel small, when you feel lost, when the world seems too wide, look up. Everything you see, from the nearest star to the faintest galaxy, was once condensed into something smaller than an atom. All of it, all this beauty, all this life, came from something that refused to stay small. And neither should you. The same laws that guide the galaxies guide the beating of your heart. The same expansion that drives the universe outward drives your thoughts toward understanding. You are the cosmos in miniature, learning, moving, expanding in ways that only consciousness can. Maybe that's the real meaning behind the phrase, the universe is still expanding. It's not just about galaxies, it's a reminder that growth never stops, that curiosity is infinite, that even in silence, existence continues its quiet work. Every second, the universe grows by billions of kilometers, and yet you grow too, in unseen ways, in kindness, in empathy, in awareness, in your ability to stand beneath the stars and feel both small and sacred at once. In the end, the story of expansion is the story of wonder itself. We came from stardust, and one day we'll return to it. But between those two eternities, we get to witness the unfolding. We get to look at the night sky and whisper, I see you. We get to marvel that anything exists at all. That after 13.8 billion years of stretching space, somewhere on a pale blue world, a being of atoms and breath can pause and simply wonder. That might be the universe's greatest creation. And so, as we drift toward sleep, let's remember this. The universe is still expanding, and maybe so are we. In patience, in imagination, in love. Sleep well beneath the same stars that made you. And know the story is still unfolding.